Light is not fast. In reality, it is so slow that it keeps us trapped in an invisible prison, a cell from which no civilization, no matter how advanced, will ever be able to escape. For centuries, we've been taught that the speed of light is the universe's greatest achievement, the ultimate limit, the final frontier of physics. But they almost never told us the uncomfortable truth. That limit is not a blessing. It is a sentence. Because when you look at the universe on a real scale, when you leave behind the comfortable diagrams and face authentic distances, you discover something unsettling. It doesn't matter how much technology you have. It doesn't matter how much energy you can control. It doesn't matter how many millions of years your civilization has been evolving. The cosmos is designed to keep you isolated. The stars are too far away. The galaxies are separated by impossible abysses. And light, the fastest thing there is always late. We are not surrounded by visible walls or artificial barriers. We are locked in by the sheer size of the universe itself, by light years that cannot be shortened, by distances that are non-negotiable. This is Impossible Horizon, and today you are entering a trap made of space and time, a trap made of light years. If what you just heard makes you feel uncomfortable, that's normal. We've been conditioned to think of the universe as a conquerable place, as a stage where technology always wins in the end. A vast place, yes, but accessible with enough ingenuity and time. That is the optimistic version of the story, the one we were told in school, the one that appears in movies and the most hopeful documentaries. But today, we are going to set that version aside. In this journey, we aren't going to talk about miracle engines or ideal futures. We are going to look at physical reality exactly as it is, without embellishment, without easy comforts. And what we are going to discover is that many of the ideas we take for granted about space exploration simply do not fit the true scale of the cosmos. Today, you will understand why the speed of light, those nearly 300,000 kilometers per second that sound so impressive, becomes ridiculously insufficient when faced with the true dimensions of the universe. You will see why the distance between stars is not a technical problem we can solve with better ships, but a fundamental barrier imposed by the laws of physics. And above all, you are going to face a question that very few dare to ask out loud. If light is so slow and the universe is so vast, are we truly condemned to remain isolated forever? This isn't a video meant to scare you. It's a video meant for understanding, to expand your perspective to the point where many certainties begin to crack. And if you are fascinated by the uncomfortable mysteries of the cosmos, the real limits of science, and questions without easy answers, now is the time to stay, because the journey has only just begun. And if you enjoy these kinds of journeys, if you are fascinated by the uncomfortable truths of the cosmos, subscribe now and leave a like. It helps me continue creating more episodes of Impossible Horizon. To understand why the speed of light is a sentence rather than a triumph, we first have to put it into context. Because numbers, when presented on their own, are deceptive. It sounds impressive to say that light travels at nearly 300,000 kilometers per second, and it is, until you compare that figure to what we are actually trying to cross. The fastest spacecraft we have ever built barely reach a few kilometers per second. Even our most advanced probes, those that have been traveling through the solar system for decades, move at speeds that, compared to light, seem almost motionless. If light is a bullet, our current technology is a snail. But here is the uncomfortable part. Even if tomorrow we developed engines 1,000 times faster than those we have today, even if we multiplied our speed by 100 or 1,000, it still wouldn't be enough. Because the problem isn't that we are moving slowly. The problem is that the universe is absurdly large. Our brains are designed to function on human scales, kilometers, hours, days. But when you start thinking in light years, in distances that require decades or even centuries for light itself to cover, intuition breaks down. Speed stops mattering when the void stretches on for trillions of kilometers. And that is what is almost never said, that the speed of light isn't slow because it isn't impressive on its own. It is slow because the cosmos is so vast that even the fastest thing in existence becomes insufficient. This comparison is key because it sets the stage for what comes next. When you begin to see the actual distances between planets, stars, and galaxies, you will understand that we aren't talking about a technological challenge, but a structural limit of the universe.
There comes a point where numbers stop meaning anything. Trillions of kilometers, light years, massive powers of 10. The brain processes them as symbols, not as realities. That's why, to truly understand the slowness of light, we need to bring the universe down to something we can actually imagine. Imagine for a moment that we shrink the sun until it's the size of an orange. A normal orange, the kind that fits in the palm of your hand. On this scale, the Earth would be barely the head of a pin, orbiting a few meters away. Jupiter would be a small cherry much further out, and Pluto, a grain of dust lost hundreds of meters away. So far, it all seems manageable, a model of the solar system that could fit in a park or a neighborhood. But now comes the part that breaks your intuition. If we maintain that same scale, the closest star to the Sun, Proxima Centauri, wouldn't be a few kilometers away. It would be more than 2,000 kilometers away. 2,000 kilometers of absolute void between one orange and the next. Nothing in between, only darkness. If you placed your orange sun in one city, the next star would be in a different country. And that is the closest one, our immediate neighbor in the galaxy. Now let's try another analogy, one even more cruel to our intuition. Imagine a normal roll of toilet paper with about 500 sheets. Let's assume that each sheet represents 100 million kilometers, roughly the distance between the Earth and the Sun. One single sheet for that entire journey that takes light 8 minutes to travel. With about 60 sheets, you could represent the entire solar system, from the Sun to the far reaches where Pluto orbits. Our entire cosmic home fits into a small part of the roll. Now for the important question. How many sheets would you need to reach the nearest star? More than 400,000. About 800 rolls of toilet paper placed in a straight line. Dozens of meters of paper just to reach a single neighboring star. And that isn't the center of the galaxy. It isn't a distant region. It is literally next door. These analogies aren't meant to impress you. They're meant to show you something fundamental. The slowness of light isn't because it lacks speed, but because the universe is disproportionately large. When you understand this, it starts to become clear that we aren't facing a challenge that can be solved with better engines or more time. We're facing a geometrical reality, a scale that is not playing in our favor.
At this point, it's tempting to think that all of this is just a temporary limitation. That perhaps we can't do it today, but we will tomorrow. That with enough technology, more powerful engines or new energy sources, we would eventually break this barrier. But this is where physics sets a definitive limit. The speed of light is not simply a high number. It isn't a record we can beat with better machines. It is a fundamental property of the universe, embedded in the very fabric of space and time. Over a century ago, Einstein proved that the faster an object with mass moves, the more energy it requires. And that increase is not linear, it is exponential. Every tiny increment in speed costs more energy than the one before it. As you approach the speed of light, the energy required grows without limit. It doesn't matter how advanced your civilization is. It doesn't matter how many stars you are able to harness for fuel. To reach the speed of light, you would need an infinite amount of energy. Infinite. Not just more than we have, not just more than there will one day be. Infinite. This means that traveling at the speed of light is physically impossible for any object with mass. And traveling faster than light is not just improbable, it is incompatible with the laws that keep the universe running. That's why the solutions we usually imagine belong more to science fiction than to science. Warp drives, hyperspace jumps, stable wormholes. Fascinating ideas, no doubt, but they require conditions we have never observed and that, according to everything we know, might be impossible. Every time physicists try to find a back door, a way to bypass this limit, they run into the same wall. It isn't an engineering problem, it's a problem of reality. The universe doesn't prevent us from traveling between the stars because of a lack of imagination. It does so because the rules of the game were fixed from the very beginning. And those rules turn enormous cosmic distances into something more than just inconvenient. They turn them into an absolute barrier.
When you understand that the distances between stars cannot be shortened and that the speed of light cannot be exceeded, an inevitable question arises. A question that has nothing to do with engines or ships, but with our own loneliness. If the universe is so vast, if there are hundreds of billions of galaxies, each with hundreds of billions of stars, many of them with planets, where is everybody? This question is known as the Fermi paradox. It doesn't claim that life outside of Earth doesn't exist. It poses something more unsettling, that if intelligent life is common, we should have seen some clear signal by now. And yet, the cosmos remains silent. One possible answer is uncomfortable but consistent with everything we've seen so far. Perhaps the universe isn't empty, perhaps it is full of life, but every civilization is trapped in its own bubble of space and time, separated from the others by distances that no technology can bridge. Even if two civilizations exist at the same time, even if both develop advanced technology, communication between them would be desperately slow. A message sent today could take thousands of years to arrive, and the response another few thousand more. By the time the dialogue was complete, both civilizations might have changed completely, or vanished altogether. Thus, the silence of the universe would not be a sign of absence, but a direct consequence of physics. We are alone because there is no one else. We are alone because the universe is too big to allow for encounters. This idea completely changes the way we look at the sky. Every point of light could be another conscious world, staring into the darkness with the same question. Not ignoring us by choice, but separated by a distance that turns any attempt at contact into something futile. And in that context, our loneliness stops being personal, it becomes a structural feature of the cosmos.
Faced with this outlook, it's natural to look for a way out, to think that somehow we will find a crack in the laws of physics, that there will be a future technology capable of turning the impossible into a routine. For decades, science fiction has explored these ideas. Warp drives that fold space, wormholes that connect distant points in the universe, ships that hibernate their crews during endless journeys. These are powerful ideas because they respond to a deep desire, the refusal to accept limits. But when we examine them carefully, they all stumble over the same problem. Warp drives, for example, don't directly violate relativity, but they require forms of energy we have never observed, negative energy in quantities greater than what exists in the entire observable universe. Wormholes, if they exist at all, would be extremely unstable, collapsing before anything could pass through them. Other proposals try to dodge the problem by changing the traveler instead of the journey. Generation ships, where several generations would be born and die during the transit, or cryogenic systems, freezing the crew until they reach their destination. But these solutions don't eliminate the cost, they only displace it. Traveling to the stars would mean abandoning the world you know forever, giving up your time, your culture, everything that defines you. Even if the journey were technically possible, the human price would be enormous. There's also a real effect, not a fictional one, that is sometimes presented as a way out: time dilation. At speeds close to the speed of light, time passes more slowly for the traveler. In theory, you could cross vast distances within a single subjective lifetime. But when you returned, if you returned, the world you left behind would have aged centuries or millennia. You would be a stranger in your own home, a traveler who arrived too late. All of these ideas share a silent conclusion. It's not just that traveling between the stars is difficult, it's that doing so while remaining human might be impossible.
After everything we've seen, it's easy to be left with a sense of confinement. The idea that the speed of light keeps us isolated, forever separated from the rest of the cosmos, as if the universe had placed an impossible limit upon us. But perhaps we are looking at this limit from the wrong angle. The slowness of light doesn't just separate us, it also gives us something extraordinary. It allows us to see the universe's past. Every star you observe tonight is not a present point, but a memory. Its light began its journey years, centuries, or millions of years ago just to reach your eyes. Some of those stars no longer exist, others have changed forever, and yet their story continues to travel toward us. Thanks to the slowness of light, the universe becomes a living archive, a record of everything that was, a cosmic memory written in photons. Without this slowness, we couldn't reconstruct the history of the cosmos. We wouldn't know how galaxies were born. We wouldn't be able to see the remnants of the Big Bang. We couldn't understand where we come from. And there is something more. If light were infinitely fast, the universe would be a brutal place, without sanctuary, without isolation. The first civilization capable of expanding could dominate everything. The slowness of light acts as a great cosmic peacemaker, allowing life to arise and evolve in countless corners, protected by distance. Maybe this invisible prison isn't just a sentence. Maybe it is also a cradle, a space where complexity can flourish, where life has time to exist, where consciousness can appear, however briefly. We are small, we are local, we are ephemeral. But we are also something rare, matter that has learned to look at the universe and wonder about its place in it. We don't need to conquer the stars for our existence to have meaning. We don't need to cross every distance to be part of the cosmos. We already are. The atoms in your body were formed in stars that died billions of years ago. The light you see in the sky has traveled for ages to find you. You are stardust, contemplating other stars. Perhaps the final lesson of the speed of light isn't frustration, but humility, accepting that there are limits we cannot cross, and yet finding beauty in what we can see. Because even if the universe is immense, cold, and silent, for a brief moment, here in this small corner of space, the cosmos has learned to look at itself, and that, even in a universe of invisible prisons, is something extraordinary.